No, not yet. Okay. So in this lecture, we'll talk about misuse case modeling. Now, this chapter is actually called chapter 10, and we're skipping over chapter 8 and 9. Not because of any exceptional reason. Actually, I should be renumbering the ordering of the lectures because I feel like natural progression after the use case modeling chapter is to teach the misuse case modeling chapter, and then 8 and 9 should actually be spread around at other parts of the course. It's not actually the first time I did this, so I need to actually like formally sit down and change the numbering of the chapters. But this is called chapter 10. We're skipping for now chapter 8 and 9. We'll get back to those a little later on. And if you're wondering, does misuse case modeling have to do with use case modeling? The answer is yes. It has everything to do with use case modeling. All right. Now, as you can imagine, the word use is to make use of something, and the word use case, that means it's a case of usage. Now, obviously, the word misuse is the inverse of the word use. But what it means also is that we're still having actors use our system, but instead of using it in a proper way, they are misusing it, okay? So the way they are using it is actually causing harm. That harm could be intentional or could be unintentional, okay? So we're gonna talk about secure software engineering, and specifically, we're gonna focus on one technique. It's called misuse case modeling. So, there's two aspects to this lecture, and the first of which, as you see, we're talking about secure software engineering first. This is going to be a full-blown course for those of you who is going to enter the cybersecurity track. It's a full-blown course on secure software engineering, and explains how to do software design, how to do software requirements, but while considering security. Maybe at some point, if I'm going to be teaching the secure software engineering course, then maybe I'll take the misuse case modeling slides and I reserve that to the other course. But for now, it stays here. Now, why should we bother with secure software engineering? Okay, right now, every system in the world is connected. You might have heard even the term Internet of Things. Anybody heard of that buzzword Internet of Things going around now? Is kind of causing a big buzz. Right, Internet of Things, yeah, IoT, you hear that all the time, IoT. And actually, the funny thing is that IoT existed long before the term IoT even actually existed, okay? So it wasn't really an advent or anything like that. It's almost like cloud computing. I mean, it existed. It's just basically the business of renting out, software or storage or something like that. And, but suddenly when a word comes out, then, the buzzword just eats up, the whole thing, right? Anyway, the point is that our systems are not isolated. Every machine, since it's connected to the internet or connected to some sort of network, it means it is vulnerable to some sort of an attack, okay? The phones that you have with you right now, they could be hacked any moment, okay? This laptop that I'm teaching you with could be hacked any moment. The computers that we have at the university, they are vulnerable, okay? Unless this machine is plugged into a power plug only, just to supply power, electricity, right? Then you rid yourself and shield yourself from all of these types of attacks. But even then, social attacks can actually be still possible, all right? For example, somebody coming in and plugging in a little USB on the side of your computer or from the behind, especially if you're using a desktop, and they plug in a little USB, that USB could be a keylogger, all right? And then you enter your username and password. It stores every single key that you type. They can figure out easily which is your password, and then you're in danger. So, but they have to do that physically twice, actually, all right? To actually come in and plug in the USB and then come in again and remove it. Anyway, our systems, be it connected to some sort of a network or not, is vulnerable to a multitude of attacks. There's so many types of attacks that exist, okay? There's the social engineering part, okay? Social engineering is the type of you just fooling the person, and you're using the person to help you, the adversary into attacking your system. We've actually seen a very recent example of that. I don't know, on the weekend, this is just very last weekend. Did you guys get this email saying you're gonna get $4,000, something like that, $4,500? Anybody got that email? Okay, so some of you've got it, okay, and there's a link that you click, and it's asking for just to put your information. Now, I hope, Abdullah, that you actually didn't put your name there. Now, this is not actually a hack. This is not a hack in the sense of that I'm going to use software to break into your system. This is what we call a social engineering attack. Now, how that works is you voluntarily you put in your name, address, phone number, email address, right? All your information, you put it in there to get the $4,500. All right. And after you enter that, all right, somebody tells you, oh no, it's a phishing scam and all that, and then you're like, so I'm so disappointed. Okay, good. And you'll realize nothing happened. Yes, nothing at this point haven't happened yet. But at some point later on, maybe a couple of months from now, somebody calls you. Somebody calls you, right? And they're trying to scam you into something. And they'll call as though they're from some sort of a legitimate entity. For example, I'm working with STC. I'm working with Mobily. Are you the person such and such? Yes. Is your phone number such and such? Yes. Your email. Now, the fact that they're giving all of this personal information about you, and you're thinking to yourself, how the heck did they get it? They must be a legitimate entity. And then they build a trust. And this is where it gets really, really dangerous. Okay. So what happens at that point, that usually what they do is they perform some sort of a transaction on their computer. All right. And it's a large transaction, obviously. It's something that would drain your account. And then they'll tell you that, we enrolled you in some sort of a VIP club, blah, blah, blah. It's free and so on, but you have to, there's going to be a PIN number that's going to be received on your phone. Can you please let me know what that PIN number is? That PIN number is not actually some sort of a club enrollment or anything like that. It's actually the code you're using to authorize the transaction. And the worst part is, from STC's perspective, they thought that they gave you that PIN just for you to see, but you've ended up giving it to someone else. Why the heck would you give it to somebody else? It's because you trusted them, because they're telling me all this information about me. They must know me, and they must be from some sort of a legitimate entity to know all of this information about me. All right. When what happened was that 2 months ago, that phishing scam happened, and they've retrieved that information at that point. Okay. So the golden rule is, the golden rule really to all types of social engineering attacks, that if it sounds too good to be true, usually it's too good to be true. Okay, that's the golden rule, right? Obviously, the other rule is never give out your PIN numbers, never give out your passwords and things like that. And we know it sounds obvious, but the problem is that when we establish a trust between us and the person on the other side, this is where we let our guards down. This is where we let our guards down and start to fall victims for those types of things. Another example of social engineering is that, let's just say you bought something at a store. All right. A person, for example, was able to figure out who you are, your phone number, and that they was actually standing right behind you in that line at that store. Okay, let's just say that store is Al-Jarir, for example, Al-Jarir store. Okay, and they ask you for your phone number, right? Al-Jarir, right? Remember that? And so some person might have just recorded that. They recorded your name, they figured you out. And so they call you and um, they call you and they say, yesterday you made a transaction at Algeria, you used your credit card, right? Unfortunately, the credit card has been compromised, so you need to create a new password. Now, what happens is that they give you a link. It's a scam link, okay? You don't pay attention to the URL because it looks very similar to your actual bank URL, and it really is nothing but it contains the actual picture, but it's a frame. So you enter your password, and then in the next step, they actually forward you to the real bank system where you enter your password again, but they already have a copy of your password, and then they can do all sorts of damage. Now, moving on from all of this, even when your system is connected, even in more trouble, because you are vulnerable to all sorts of internet-based or network-based attacks. If you're dealing with cryptocurrency, Bitcoin and so on, you are vulnerable to cryptography type of attacks. So cryptography is all about you're ciphering a piece of text, a code, which is a transaction code. You're ciphering it, and there's a key, and it's all about that so nobody figures out what that key is, because otherwise they can do all sorts of damage with that key. Bottom line is we got to build those systems to be trustworthy. It doesn't matter how much functionality, how much amazing functionality it is. Some systems, they have to be trustworthy. And if you don't feel that they are trustworthy, basically they end up being rendered useless. All right. So if you have a banking system, it's really amazing and it's got all these cool features and so on, but somebody tells you that, your information is made public if you actually use that system, then you'll say, the heck with it, I don't want to use it. I'd rather use another software system, another bank that has a more primitive website, but that is actually secure. Okay, something that basically just tells me what my balance is and that's it. I would rather use that than use another fancy website that actually causes my private information to be not private anymore. Having said so, it's not good enough to just unplug from the rest of the world and say, I'm going to stop until this attack is finished. We got to continue to operate. Okay, here's the trick in all of this. We got to continue to operate. So not because we're under attack, that means we stop. Okay, matter of fact, one very, very popular attack is not even based on penetrating the system to begin with. Okay, so I can attack you without even having to bother to even enter your system at all. And I could do it from the comfort of my home. Can somebody tell me what that name of that type of attack is? No? It's called a denial of service attack, a DOS attack. It's gotten popular about 10 years ago or about 12 years ago. All right. And this is hence why you see all these CAPTCHA. You must have come across these CAPTCHA things, very annoying CAPTCHA things, right? Which is to prove that you're a human being. CAPTCHA, guys, hello? Anybody, you see a text and they ask you to write the text or something like, okay, good. So you're still alive. Now, the whole CAPTCHA thing is to prove that you're a human being. Why is it that you're proving a human being? Is that because there's software that is built by attackers. We call that a bot. A bot is a piece of software that pretends to be a human being. And all it is, it just keeps overloading your servers with fake queries. And so you're busy, your server is busy responding to these fake queries. And now it's not really available to the real users of the system. And that causes a very, very bad, impression. I mean, let's just say you got onto a website to book an airline ticket, and you got on the website of that airline and it says website not available right now. You probably just have a bad impression about this whole airline to begin with. And you say, that airline doesn't look good, I'll maybe book with a different airline. Okay, so that's called a denial of service attack. We have all sorts of mechanisms that exist, be it cryptography, intrusion detection systems, firewall, antiviruses, and all that stuff. These are generic defensive mechanisms. Now, the reason we say generic is because they don't know the domain or the business of that software that you actually built. Okay, they don't know the business of that software that they're actually protecting. They're just performing generic defenses. Okay, for example, a firewall, all its job is that it permits certain data to pass through certain ports. It has no idea what's inside that data. Okay, so if the proper data is sent to the proper port, then firewall doesn't do anything for you. Okay. In secure software engineering, the philosophy here is that we need to address the security requirements at the engineering phase from the very, very beginning. Okay. Now, basically, the premise of secure software engineering is that we are going to get the system to defend itself, not just to wait outside for those generic defensive mechanisms to help us out. Okay. Now, the way we look at secure software engineering back in the day is that we build a system, and then afterwards we decide what are we going to do about security. Let's slap on these generic defensive system, firewall, antivirus, intrusion detection systems, cryptography, and the like. All right. And that's the way it's been for years and years, so many years. Okay. We only have those defenses and that's it. Okay. But then the issue is that while these types of defenses repel a lot of attacks, so they're still very, very useful. Every once in a while, can you tell me what happens? Can somebody imagine what's going to happen every once in a while? It's pretty obvious. Exactly, a breach. Somebody gets through, all right? And then cue the Hollywood movies where you see a hacker who's always wearing a hoodie for some reason. I don't know why. I don't know what it is about the hoodie thing, but they're always wearing a hoodie. And that hacker is typing frantically on the keyboard. We've all seen those Hollywood movies. And then there's the breakthrough. It was Rihanna once. What are you talking about? Anyway, so we got to talk about this a little later on. Anyway, so you see in the Hollywood movies that the hacker is typing away frantically on their keyboard, and they get that breakthrough. There's always that breakthrough moment where they slam on the enter button. And what do they always say once they slam on that enter button? You know, right? Exactly. I'm in. Good job, Sarah. And actually, I'm in is very descriptive of reality. What it actually means is that once I'm in, I'm free to roam around and do whatever the heck that I want. Nobody can touch me. Nobody can touch me. All I have to do is I have to worry about maybe a certain amount of time before I gotta go get out of there, because maybe the real person is the legitimate person is gonna log in now, and they realize that they're already logged in. Okay, so I gotta get out before it's 8 a.m. Another thing that I gotta worry about is that when I'm leaving, I remove all sorts of traces of me connecting. So making sure that I don't leave a backlog here, so nobody can trace me. And then you've been hit. You just have no evidence it was me. All right. So that's not good enough. And secure software engineering says I got to defend the system myself. Okay. Now, what does that mean to defend the system? Let the system defend itself. Basically, we're going to let the system, by knowing its business, so to speak, it can figure out that some pattern of usage is actually a misuse. Okay. A classical example of that actually existed before even secure software engineering came into light is that when you stand in front of the ATM machine and then you enter your PIN number 3 times in a row and it sucks in your card, that's not a firewall or cryptography or intrusion detection system. That's basically the programmers of the ATM machine, with some common sense, realizing that if you enter the PIN number 3 times wrong in a row, chances are this is not your actual card. Okay, so we're gonna take it away. If it really is yours and you just happen to forget it, you might as well just visit the closest branch. And and if it's not, then we've saved the real user, the real owner of the card from a thief. Okay, I'll give you another example. All right, maybe not so common of an example. Okay, in the world of academia, it does happen, although very rare, that we do a grade change. Okay, so student can come in, they might petition or say, can I just take a look at my paper or whatever it is, right? This official, and then realize, oh, we've done a mistake. There is a good case here, and the student's change should be great, should be changed. First of all, this happens rarely, but when it does happen, tends to be that the flip in the grade is normally just one grade. Okay, so from a B minus to a B, or a C to a C plus, or A minus to an A, right? But if somebody goes from an F to an A, that's really a massive change, correct? That's a change that is worth, hey, wait a minute, what the heck happened here, so to speak, right? I mean, if there's somebody, a human being at the registrar, who actually looking at it manually, they say, how could the grade be so wrong, unless it was a typo, that it goes from an F to a change of an A, right? Now, it's not to say that it's impossible. Maybe the student didn't actually attend the final exam, but now that they've attended it and so on, blah, 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 right? But the point is, this is one of those grade changes that need to go back and maybe even physically ask the professor who's responsible, say, did you actually approve that grade change? And what's your justification for it, right? And then if it happens to be a hack, then this is the professor where they say, wait a minute, I never actually approved this, okay? Somebody could counter this and say, okay, so it's a cat and mouse game thing, so how about I keep doing multiple grade changes? Okay, so I go from a C to a C plus, from a C plus to a B minus, and B minus to a B, all the way to an A. Well then, again, the system should pick up that given that grade changes are very, very infrequent, the fact that it changed so much for one particular student in itself is worth, another look. And then again, we gotta contact that professor physically and say, hey, did you approve all of these grade changes to that student? And why? And chances are they're probably not legitimate changes to begin with. All right. Now, we can only get the software to do this by coding something, right? We got to write code, right? We got to have a counter that counts how many grade changes has happened. We can do that, right? Int grade change counter equals 0, semicolon. And then every time it changes, then we add a 1, right? Very easy, but we got to code it ourselves, okay? A firewall is not going to do that for us. An antivirus is not going to do that for us. All right. When we make a grade change, we can count how many grades did it change. Is it 1 grade flip, 2 grade flips, or is it 5 grade flips? All right. And this, we can code it. Again, int, grade difference. And then we have an int variable, 0, 1, 2, 3, 4. And then we can set an if condition to trigger some sort of a security check if it sees a particular threshold. Now, you'll say, all right, well, if that's the case, I'll just code it. But then we're software engineers. We don't just go ahead and we do straight coding, okay? Everything that we code, we design for it first. And so if the implementation is going to have security code, then that security functionality needs to be designed. And to design the security functionality, I got to figure out what are the security requirements of the system. Okay, so all of this examples of how the system should defend itself, I've just explained it to you during this lecture, and this is, I'm doing security at the level of requirements engineering for the designers to go ahead and design security into the system and implementers to implement that secure design. And even when it comes all the way down to testing again, we are testing that the secure functionality, the functionality that we have there to allow the system to defend itself is actually working properly. Okay, because again, like I said, we're software engineers, we're not computer scientists. All right, so the same waterfall method, be it waterfall, be it some sort of an agile methodology where you're going through these different phases in small sprints, we got to take security into account in each and every one of those. Okay, and this is why we call it secure software engineering. All right, and again, like I said, as you can see here from this slide, okay, the purple line, you see the basically, sorry, it's on the white line, I mean, the waterfall processes, and then at each step, we can do certain things to help us make sure that we have designed things properly from requirements all the way to the actual testing, okay? What we're going to be focusing on in this lecture is something called misuse case modeling, and it relates to requirements engineering, in other words, secure requirements engineering. Because this is a requirements course. Now, requirements engineering, misuse case modeling, it uses the same notation as use case modeling, but it adds to that notation. It doesn't add that much to it. Okay, so you don't have to panic here. It doesn't have to add, you don't add that much to it, okay? But basically, the misuse case is what you see on the right-hand side of your screen where it says steal the car, and you see the colors are inverted. Now, this color inversion is symbolic, okay? It's still using an oval to show you that it's a functional thing that it's gonna execute, except that that functional thing has negative consequences. So you can think of it that the misuse cases are negative use cases. And the actor who's involved, we're going to take a look at that in a moment, is a hostile agent. All right. Now, the actor tends to have a black color, as you see over here. And again, it's symbolic in the sense that it's the same as the regular actor, except that they're there for a negative purpose, an inverse versus of what the actual legitimate actor is. Now, remember at the beginning of this lecture, I said that a misuse can happen intentionally, or it can actually happen unintentionally. So you can see an actor showing up in a use case diagram with the regular use case, but you can see an actor actually shown as a misuser. Okay, so the opposite of an actor is a misuser. And it will have the same exact name. Okay, for example, a professor could be a legitimate user of Moodle, but I unintentionally, the professor, could also end up using Moodle system and unintentionally causing some harm. So I would be a misuser, and I would also show up on the right hand side of the diagram, all right, depicted as a misuser. Okay. Misuse case modeling is valuable for hazard and threat analysis, and it's good for eliciting requirements more specifically. security requirements, which is then helpful for us to figure out a design that will realize those security requirements, the functional security requirements, and will also help us generate test cases to test that the security requirements are being executed effectively, are functioning correctly. So a misuse case model, it models the functional security requirements, just like use case modeling models the functional requirements. It's an extension of use case modeling, and as I said, and it comes with a result is a misuse case diagram. A misuse case diagram would have both the use cases and the misuse cases. We'll see an example of that in a moment. And each one of those misuse cases will have a textual description as well. Okay. So this is a very, very primitive example of a misuse case. All right. And the left-hand side is what we're familiar with. We have a customer, they're submitting a purchase. Okay. But as they're buying something, a crook might want to steal their credit card information. And then, so that threatens that use case. Okay. Now, this misuse case over here called, let me put the laser pointer here for a second. So what this threatens means that while this use case is executing, that misuse case can also execute to threaten that use case. And then what you usually see is that the regular use case will call upon a security use case outside, and it's not part of the business. And we do that to mitigate against that misuse case. Okay. And then that misuse case also can have like its own extended family of misuse cases, they include and extend relationships. For in this particular example, the steal credit card information, as it was trying to steal it, it was realized that my intrusion has been detected. So now I got to get out of here very, very quickly before I get caught, and maybe delete all the information and so on, so that police enforcement is not at my door within 10 minutes. Okay. So that's just in a very, very high level approach, high level description of what the notation is like. Now, more specifically, the misuse case diagram comes with two new notations, two new relationships. The first of which is called the threatens. The threatened relationship can only exist between a misuse case and a use case, and it will always be pointing from a misuse case to the use case. Meanwhile, the mitigate relationship can only exist between a use case and a misuse case, and it can only be directed from a use case to a misuse case. All right. So I think that's definitely pretty clear. All right. The include and the extend and the generalization and implementation, all that fun stuff that we knew, just as it does exist between use cases, it can also exist between misuse cases as well. All right. But it cannot exist between misuse cases and use cases. So you cannot have an include between a misuse case and a use case. You can have you can't have an extend. You can have a generalization. You can have an implementation that is combining both a misuse case and a use case. We cannot have that. All right. Associations can exist between a misuser, okay, and a misuse case, just like it does between an actor and a use case. It cannot exist between a misuser and a use case, and it can also cannot exist between an actor, a regular actor, and a use case. So mixing and matching is not allowed. The only time the world of misuse touches the world of use case and vice versa is through the threatens and mitigates relationships. And threatens points just from the misuse case world to the use case world, and the mitigate relationship can only point from the use case world to the misuse case world. Now, I just want to say that the word threatens doesn't mean that some damage has happened, okay? And maybe that's a deficiency in the notation. I mean, it doesn't actually say when it has actually happened and so on and so forth, okay? So, all it's trying to say is that there is a threat, and we got to watch out for that threat. Similarly, the word mitigates is not a guarantee of defense. All it's trying to do is mitigate, it's trying to balance out, it's trying to alleviate maybe to some 90%, 80%. We're trying to get to 100% if we can, but this is what we call mitigates. We're trying a best effort to stop that harm caused by the threatening misuse case to happen. All right. So here's an example of a misuse case diagram. There's even bigger examples that I will be putting up on Moodle. All right. I will leave that up to you to read. But as you can see, you can see an include between misuse case and another misuse case, fine. All right. An extend between a misuse case and it's fine. Again, include, this is the regular stuff that we're used to. All right. You can see that the threatens always goes from a misuse case to a use case, and the mitigates always goes from a use case to a misuse case. All right. Associations between misusers can only be with misuse cases. Association between actors can only be between the actors and use cases. Even the generalization relationship that existed between the actors and the misusers, you cannot have a misuser being a sub-child of an actor and vice versa. You cannot have that. Okay. Now let's read this a little bit more carefully, huh? So we have an actor is a voter. He's trying to submit their vote. All right. We are at a threat of having our vote revealed, okay? And vote reveal, think of it as a special case of stealing of sensitive information, okay? And so we're gonna include a security use case, so to speak, to mitigate against the stealing of that sensitive information, okay? Now, this over here is what we call a triangular pattern, okay? And it's very, very common in misuse case modeling. This triangular pattern tends to be in that following format, okay? So we start off with the business use case. This is what we've been doing so far in the previous chapter. And then the new thing comes in. We have a misuse case that says, I'm going to threaten you. Okay. As this functionality is executing, by the way, when I say as, doesn't mean it has to be synchronous. It could be asynchronous too. All right. I'm going to threaten you. So next up, I create a mitigating use case. Now this mitigating use case, it has that security functionality that allows the system to defend for itself. Okay, it is not part of the original business use case. It's not something that we would have thought of had we never thought of our system being under attack to begin with. Okay, so this is very critical. All right, all of this side of the screen would not exist back in the day. We just create those, we design them, we implement them, and then at the end of the day, we slap some sort of a generic defensive mechanism, like I said, like a firewall or something like that. All right. So we have that business use case will include, and we tend to say it's an include because we're not going to wait until to see if we're going to be threatened or not. We have to include it, make sure that we do our defensive mechanisms functionality up front. All right. Okay, so when a grade change happens, I'm not going to wait. I got to do the check to make sure that it's within the thresholds of what a logical grade change should be. And then finally, we have that security use case, the mitigating use case to mitigate that misuse case over here. All right. So if a misuse case doesn't have a mitigate relationship to it, that means we've overlooked it. Okay, so we have no defense against that misuse case. The misuse cases that we want to defend against are mainly the base. Yeah, there we go. Okay. Now, it gets a little bit tricky because this triangular form is obviously, it doesn't just come in that form by itself. The use cases have other relationships, even misuse cases have other relationships with other use cases. So you can see something like, you know, a stitch over here. I mean, we're actually seeing the triangular form over here. And basically, all the extensions and the inclusions of that base use case over here is defended by that mitigating use case. Okay. Similarly over here, any other misuse cases that it's extending or being included by that misuse case is mitigated by that mitigating use case over here. All right. So we don't really care about the leaves. We care about the base. Okay. We care about the base. Let me step out here for a moment. I want to open up the whiteboard here for a second. Just make sure I have the Microsoft whiteboard. Where is it? There we go. All right. So let's do this here. Now, did I not share it? Doctor, that's the difference between what exactly, Lubaba? Oh, what's the difference between business? Okay, so yes, that's a very good question. Okay, so guys, again, the difference between a regular business. Why is this thing? Oh, just a moment. I don't know why my pen is not working. Just give me a moment, guys. To answer your question, Yalubaba, so a business use case is what we would normally have just as a regular use case that has functionality that that realizes our business needs. Okay, so if you're looking at, say, an airline, okay, you got to book a ticket, make reservation, change the reservation, cancel a reservation, that sort of thing. Okay, choose a seat, choose a meal. These are the functionalities that are related to the actual business needs. Okay, mitigating use cases are actual still regular use cases, but they've only been there because we're afraid of certain threatening behavior that's going to be caused by these misuse cases. So I create them. Okay, I create them in order to allow the system to defend for itself. Okay, had I not ever expected a student to come in and hack into the grading system and attempt to change the grades, I wouldn't have bothered with creating that functionality that allows the system to defend itself against illegal grade change. Okay, that's the whole point about the difference between a business use case and a mitigating use case, sometimes called a security use case. A security use case. All right. One very important note that I want you to be aware of. Yeah, exactly. It's like shielding. Yes, it's shielding, but the shielding comes in the sense of it's not like a firewall shielding where I'm preventing a penetration. The shielding comes in the form of I'm going to execute code to do a check to make sure that whatever functionality is being executed. So you're in now, but you're not free to roam around. Okay. So even if you were able to hack into the registration system, you're still not able to change your grades illegally. Okay. You might get away with changing it from a C to a C plus. That's basically the most you can do, right? And it's a way of getting the system to defend for itself rather than just depending on solely those defensive mechanisms sitting outside. Now, something that we gotta be aware of, okay? Those mitigating use cases or security use cases are use cases that are gonna turn into code just like regular business use cases. However, misuse cases, they're not things that turn into code. We never actually code our own threat ourselves. We code the defense against the threat. Okay, but we don't actually create code to do the actual threat. That's like grabbing a hammer and hitting your own foot with it. All right. So that's definitely not what you want to be doing. Okay. You want to wear the protective gear. All right. And that's it. And hope that the attack doesn't come in. But if it does come in, that you're ready for it. Okay. Let me go back again to the slides. All right. So like I said, I got more bigger. Yeah. Let me do something here. All right. So this over here was a quiz that I brought before. All right. I want you to pay close attention to this. All right. I'm going to be going back and forth in order for you to understand. But anyway, given the misuse case diagram above you here that you can see, what would be the syntax errors in that diagram, given what we just learned today? And then those of you who entered late, let me remind you that did somebody who actually did that? That's actually pretty cool. Okay, so that's right. Misuse case C should not include Naif. Oh, that's pretty amazing. So that's a good job, Naif. So yeah, a misuse case cannot include a use case. Okay, what else? Anybody can spot any other issues? Yep, that's correct. Who did that? The second one? Muhammad. Okay, good job. I think somebody else was. And I believe there's another one, if I'm not mistaken. I have to look a little carefully. No, I think that's it. Not sure if there is another one. No, that's fine, Alibaba. You can have a generalization relationship between misuse cases. That's fine. Okay. I don't know why I can't acted to misuse case. Oh, yes, there you go. Yeah, that's right. Who said the last one? No, I'm so sorry about this, guys. Okay. Um, Unfortunately, like I said, there's something else that I actually want to explain to you about misuse case modeling, but unfortunately, the pen that I have, the sketch with, is not working. I gotta go fix that as soon as possible. So we're gonna stop here for today. All right. There's another question at the end that we're gonna also look at in the next lecture, but the type of question that you can get on an exam would be something like this. Okay. So in your next quiz, and surely you're gonna have a quiz about misuse cases, you're going to be seeing one of those questions on the quiz, and you're gonna be able to figure out syntax errors. You need to be able to do critical analysis of determining those triangular forms of the misuse cases. Okay, guys. All right, so that's it for today. I will see you, inshallah, on. Doctor, I didn't find this. Yeah, yes, I still don't. I didn't put it up. I'll put it up today. Okay, it's just an example of a big misuse case item. Okay, so I'll see you guys on Wednesday, inshallah. Have a good day, everyone. And by the way,